The iCommands are Unix shell commands that implement the data manipulation and administrative functions supported by data grids. The original client to the iRod's data grid was a set of Unix shell commands called iCommands. They remain the most powerful interface and provide many options that are not supported through web browsers or WebDAV or CyberDuck. Examples include support for bulk operations, support for parallel I/O streams, support for administrative tasks such as user creation and resource creation. The iCommands for manipulating files are modeled after the Unix shell commands. The command names are similar to the Unix shell command names, with the addition of the letter I at the beginning of the command. For example, in Unix, cd changes directory. Changing a directory in the iRod's data grid is icd. chmod changes access controls. To change access controls in the iRod's data grid, ichmod. cp copied files between directories. It changes to icp. ls to list files changes to ILS. MV to move files between directory changes to IMV to move files between collections in the iRod's data grid. PWD lists the current working directory, changes to IPWD. RM to remove a file changes to IRM to remove a file from the iRod's data grid. The iCommands apply the operation to files in the data grid, while the Unix commands apply the operations to files on your laptop. The operations needed to manage a policy-based data management system are much more extensive than the commands used to manipulate files on a laptop. Operations are needed to load files into the data grid, IPut, retrieve files from the data grid, IGet, manipulate metadata, execute rules, and list resources. The commands include iChecksum to create a checksum, iExecCommand to execute a remote command, iGet to get a file from the data grid, iHelp to list the iCommands, init to authenticate access to a data grid, ilsresc to list storage resources, imeta to add, remove, or list metadata on a file or collection, iPut to put a file into the data grid, iQuest to query metadata, iRepl to replicate a file, iRule to execute a rule interactively, and iXMessage to send or receive a message. The iCommands have to be installed on your computer before you can use them. To simplify installation, they have been packaged in a Docker image. The Docker technology has two parts: a Docker engine, which understands how to interact with your laptop operating system, and Docker images, which contain the applications that will be run. This simplifies the porting of applications to your laptop. Information about the installation of the Docker image is available at hub.docker.com. Docker engines are available for Unix, Mac, and Windows. Information about using the Docker engine and installing a Docker image containing the iCommands is available at iRod's on Docker-update. We will go over the commands to install the Docker engine on a Mac and to install the iCommands Docker image. The steps for installing a Docker image on a Mac are listed here. Go to the help page, docs.docker.com/mac/started. This describes the required steps. The next page provides information on use of the Docker Toolbox for installing the Docker engine. Go to the Docker Toolbox page, www.docker.com/Docker Toolbox. Click on the Download Mac button. Install Docker Toolbox by double-clicking the package or by right-clicking and choosing Open from the pop-up menu. The installer launches the Install Docker Toolbook dialog. Press Continue to install the toolbox. The installer presents you with options to customize the standard installation. By default, the standard Docker Toolbox installation installs binaries for the Docker tools in their user local bin, makes these binaries available to all users, and updates any existing VirtualBox installation. Change the defaults by pressing Customize or Change Install Location. Press Install to perform the standard installation. The system prompts you for your laptop password. Provide your password to continue with the installation. When installation completes, the installer provides you with some information you can use to complete some common tasks. Press Close to exit. The Docker image containing the iCommands is provided by the iRod's consortium. The Docker image is able to retrieve the image from the Docker site. Use the Docker Quick Start terminal to create a terminal window and execute the following two commands to pull down the image and install the iCommands. In the terminal that was created, type docker pull irod/iCommands: 4.0.3. This downloads the iCommands image from the Docker site. Then type docker run --name space irod space -v space /users /your laptop account /ltl space -ti space irod/iCommands: 4.0.3. This mounts your laptop files under the name LTL and names the container iRods. You will need to create a user within the iRods container and initialize the connection to the lifetime library. Type add user space --system space -u space 1000 guest. This enables write access to your laptop from the Docker engine. To connect to the iRods data grid, type IINIT and respond to the prompts. For hostname, enter diamond.ils.unc.edu. For port number, enter 2247. For your iRods username, enter your username in the lifetime library. For zone, enter lifelib zone and enter your iRods password for connecting to the lifetime library. This creates an environment variable file in the .irods directory, which will be used for future accesses. You will still need to run the init command each time you restart a container. You will be able to apply the iCommands on files within your laptop and execute rules. For example, typing irule-F and the rule name will run a rule in the lifetime library. Commands for manipulating Docker images and containers are provided. You exit from the container by typing exit. The container is not deleted and can be restarted and attached to be able to execute iCommand. Docker images lists the available images. One of these will be the irod/iCommands: 4.0.3 image. Docker ps-a lists the available containers. One of them will be the iRods container. Exits from the container. Docker restart iRods restarts the iRods container. Docker attach iRods connects to the iRods container. You may need to hit a return to see a prompt. Docker rm container name removes a container. Docker im image name removes an image. Take 7 minutes to complete exercise 24. Install the iCommands using a Docker image. Try loading 5 files into your lifetime library collection using iPut. Try listing files in your collection using ILS. Please load a paragraph describing what you did into the lifetime library in the sub-collection class INLS 624 by the end of today's class. The University of North Carolina at Chapel Hill provides a repository for researchers. The Carolina Digital Repository, or CDR, has been in production use for 5 years. The Carolina Digital Repository manages collections for UNC researchers from multiple departments. The goal is to ensure long-term access and safekeeping for scholarly works. Representative collections include master's papers from SILS, electronic theses and dissertations, Southern Folklife Collection digital files, research laboratories of archaeology, and Carolina Planning Journal. Access controls are enforced for protected material. A total of 130 collections are managed, comprising more than 356,000 images and 35,000 audio files. The URL is cdr.lib.unc.edu. The SILS Masters Papers collection contains 1,807 papers. The CDR uses an iRods data grid to manage replication of the material into an archive. The CDR software integrates 3 major components: a system to manage curation called the Curator's Workbench. This server is used to organize the collection, verify consistency of descriptive metadata, and manage ingestion. An iRODS data grid. The data grid manages long-term preservation of the material with multiple copies of the collection created both on-site and off-site. A Fedora Commons digital library. This manages access to the collections, including search and discovery. An external indexing system is used for searching, and a web interface is provided to simplify access. The SILS Masters Papers collection can be searched by subject or metadata or by the World Wide Web or by academic libraries. The topics are ranked by the number of master's papers in each area. A search on the word iRODS in the title of a paper finds one master's paper, iRODS Hive Integration, a metadata annotation system in DFC Data Grid. The processing steps for adding material to the CDR have evolved with the chosen technology. The challenges have been verification of submitted descriptive metadata. The inclusion of a curator's workbench was essential to ensure consistency and completeness of metadata. Support for bulk ingestion. Materials submitted from the curator's workbench have to be registered both in the iRODS data grid and in Fedora. One approach is to submit a file to iRODS, which then generates information that is deposited into Fedora. An XML file is created for an AIP, which is then deposited back in iRODS. Technology evolution. The Fedora Commons has changed from an architecture based on content data management to an architecture based on linked data. This improved scalability, provided integration with external triple stores, and supported a complete audit history for all repository content. Multiple systems are now available for long-term storage of digital content. They include cloud storage, Amazon and Oracle, and the Digital Preservation Network. Both systems are considered to be deep archives. Material is deposited and only referenced if an external copy is no longer available. The charges for reading material from the deep archive may be sufficiently expensive that most data are never read. The Digital Preservation Network, DPN, is working with multiple groups for integrating systems that will stage data into the deep archive. One candidate is the iRODS data grid. Policies would control the replication of files from a local staging area into the DPN network. Policies would also be needed to manage the recreation of a collection that has been lost, with the goal of minimizing the amount of material that must be downloaded from DPN. The SILS Lifetime Library has a goal of constructing a full text index of the SILS Masters papers. Since the papers are deposited into an iRODS data grid, federation can be used to enable the Lifetime Library to access the master's papers. A full text index can then be constructed in an external index. This would greatly improve the ability to search and discover relevant papers. A longer-term goal is the federation of the multiple data grids in use at UNC. An example application is federation of the CDR with the NSF-funded Big Data Hub to enable wider access to educational material by schools throughout North Carolina.